Yeah, so I'm Amiram, and the presentation I'm gonna present is about running ScyllaDB on Amazon EC2 Spot instances, how to save a lot of money by running ScyllaDB on actual Spot instances, how to leverage the Scylla capabilities, the high availability of Scylla, and combining it with the low cost of EC2 Spot. Good, so good afternoon, everybody. My name is Amiram. And I'm the CEO and founder of Spotinst. I'll tell you a little bit about what we do and how we integrate with Scylla. So before, the template has a slide, so I need to talk about myself. Does somebody know what is that picture? Not me, the other one? That's Iron Dome. Somebody heard about Iron Dome? Oh yeah, so I was lucky enough to be one of the architects of that platform when I was in the military in Israel. That's my background. I was running the data center group at the infrastructure unit called Mamram in the IDF. And after that, I just went to work for some company for a while, and I started a company with my military fellows. And what do we do in the company, and how does it work with Scylla? So Spotinst, we founded a company about 2.5 years ago. We're a startup company. We grew quite fast. We're over 60 employees in the company today. We raised some money from VC. We're based here in the Bay Area, in London, in Tel Aviv. We grew quite fast. Right now, we're working with over 1,000 active customers in the platform. And what we do for them is, let's start from the problem and how we solve it for them. So if you look at AWS, Google Cloud, Microsoft, Alibaba, they all build data centers and they sell us infrastructure as a service. And in order to sell infrastructure as a service and to keep their promise, which is provide anybody infinite amount of capacity at any given moment, they must keep some headroom in their data centers. So how much headroom do you think that they keep in their data centers? Roughly numbers. How much? Almost. So we're talking about headroom of about 40%. They must maintain 40%, which is not being utilized at any given moment, so they can support spikes. Think about AWS. I know Shell want to launch some computation about whatever. They want to launch right now 1 million cores. They want to get 1 million cores, and AWS must have available 1 million cores. But by doing that, so you can imagine, and I saw that in the military, if you're running a data center, so maintaining this 40% headroom costs a lot of money. So what this guy did is created something about like 9 years ago called Spot Market. And Spot Market is, I have an idle capacity. I will sell it in very cheap pricing. However, I have 0 SLA. So how does the company really use it if you have 0 SLA? So for that, in terms of like how many instances Spotinst is managing for customers over the year, so what we do and what the product does for these companies is actually bringing SLA to these Spot resources, and I'll explain how we do it, and actually managing those instances for them. So by tracking the capacity trends on AWS, on Google Cloud, and on Microsoft Azure, we're able to stick SLA, to put SLA into those resources. So how it actually works is a SaaS platform, and we tell customers to run anything which is not a single point of failure. Because if it's a single point of failure, that's not our problem. The customer probably needs to take care about it. And if it's not a single point of failure, we can handle it. So it's basically a SaaS platform that puts some machine learning on top of the changes in the capacity trends on the public cloud providers. And according to those changes, we know to allocate the right resource in the right time and to actually make a decision when to replace a resource before it will be interrupted by the cloud provider. And obviously, and that's our core IP and our core technology, which is prediction. For over 3 years, what we do is we're looking on data sets of AWS, and we're tracking different AWS users and Google users and Microsoft users, the way they are spinning up capacity. So we actually know, and we have data behind the scenes that we know that on Mondays, People are using more capacity on Virginia, and on Sundays, people are using less M4 instances and more i3 instances, so we can actually know which type of capacity we should buy at any given moment. And by doing this, it gives us the ability to actually take clusters, whatever cluster it may be. It can be a web server. It can be even a database like Scylla, because it's a fault-tolerant database, and run it on very cheap resources and actually provide you with a uptime guarantee. So how does it actually work with ScyllaDB? When we look about stateful apps, what's so important to us is, especially with Scylla, for those of you who configured Cassandra or Scylla, you know that the nodes must have the same IPs. And if we replace a node, we can't really replace it to tier the cluster and just bring another resource. We need to make sure we're maintaining the same IP address. We also need to make sure we're maintaining the same root volume, the same operation system volumes, because we're maintaining some logs, some configuration files. We also want to keep the data volumes from the exact checkpoint that we stopped writing into, right? We have like logs that we're writing. We have the data of ScyllaDB. And another point which is very, very important is not all at once. If I have like 6 nodes and I can tolerate only 1 or 2 nodes that will be out of the cluster at any given moment, because my data is being spread across the cluster in a certain way, so I cannot lose more than 1 or 2 nodes at a row. So that's also something that needs to be considered. And also cluster awareness. So we'll talk about it later how Scylla does that. But cluster awareness and cluster rebalancing means that if a node goes down, so right now, what will be the threshold from like losing that node until Scylla will rebalance the data differently between different nodes to maintain the fault tolerancy? So all of that sorted out through an integration with ScyllaDB, which we announced about a couple of months ago. So we can help actually customers who want to run Scylla on the public cloud to use it from public cloud providers with about 80 to 90% discount of their compute part. So how does it actually work? Do I have here? All right. If you see that every single, for example, on AWS, every single EC2 is composed from several components. One of the components is the actual hardware, the actual EC2, right? And this EC2 has an ENI. ENI is Elastic Network Interface that brings that EC2 the private IP. This EC2 also being provisioned from an image, right? That's that square here with the orange small squares. That's the AMI. And then the data of Scylla is being stored on EBS volumes, right? That's the best practice. You can also do it on ephemeral drives, but it's for more performance. But usually people do it on EBS-backed devices. So what happens if that instance goes down? And an instance might go down, right, because of several reasons, like hardware problem. But here we're talking about a price issue. So AWS wants to reclaim that back. So what do we do right now? So we actually spin a new instance. And then we just keep the same ANI. We make sure to snapshot the root volume at real time. So you will be recovered with the same root volume. And then we're using a technology called hot EBS migration. So we're just detaching the EBS volumes from your existing instance and attaching it to the newly created one. And we're considering like AZs, moving between AZs, or staying in the same AZs. Let's continue. I'll try to show you an example. So I think the 4 main components that actually make that integration work is these actual technologies that we're using. So first of all is the gossip protocol, which is being used by ScyllaDB to actually replicate data and to communicate between the different nodes, where the data is and how should we maintain every block in each node. So when we have 3 node clusters with the right replication factor, we know that we can always lose 1 node and still be in business. It might be a little bit slower, but we're still in business. The second thing is the Scylla YAML file. And in the Scylla YAML file, we'll define all the IP configuration, the rack awareness consideration, and how the host can actually communicate with each other. The third one is a rack consideration. And that's, I think, it's a tip to use anyways. Reconsideration, we see it in a lot of NoSQL databases and engines, is that if you're using on a single region on AWS, however, you're running on multiple AZs, so you would want to let Scylla know about it. So each group of servers in a different AZ. So if AWS has a, for example, disaster and one AZ is down, so the gossip protocol of Scylla can actually replicate the data evenly and equally across these different recs. And the fourth thing, which is also done, is the ODBS migration. If you look at the image here, so whenever there is a failover of EC2, so a new EC2 is being spun up, but the same drives, the same hard drives are being attached to the newly created instance, so it keeps the same node launching and just getting the same data. Let's start with an example. You see screenshot here. Everything starts with a 3-node cluster. It's like the minimum cluster that we can possibly get. As you see here with the node tool, we see 3 instances which in state of up and normal, meaning they're in the cluster and operational. And right now what we will do is we'll take one of the nodes and we'll just simulate a spot termination as if like AWS were terminating this instance. So we'll go into AWS console, we'll click, we'll take the instance and we'll just cancel the spot request. Are you sure? Yes. Then we'll go, that's our dashboard, by the way. So you'll see that once we're terminating the instance, so a new operation will start, which calls stateful replacement. Stateful replacement means that that instance, we need to maintain the state while we are replacing that instance. So you'll see what happened in a few moments. So right now, if we run the node tool again, so you remember that second instance, the 172, 31, 24, 196. Right now, it's in state down, but in state normal. It's not going out of the cluster because Scylla is kind of like recognize that this node is out of the cluster, but not completely out of the cluster. So it's probably this node is doing a reboot or needs to be replaced. Then during that time, it takes about like 3 to 5 minutes. What happens is that we're doing a sequence of operations. First thing is we're waiting for the instance to be terminated. We're taking final snapshots. Once we have the final snapshots, we're creating a new image so we can create a new instance from that image. We're launching that instance. We're attaching all the Elastic Network interface and data volumes. And once we have all of that, you can see that, again, the same command of node tool status gets the same instance with just right now it's operational and it's up, and joining again to the cluster and starting to be replicated again as part of the ring of the cluster. So what we saw here that still we see that on many large enterprises and even startup companies that when they're running large NoSQL clusters, they just accept that it costs them so much money. But here is kind of like a low-cost option, alternative to run clusters in a highly available manner, but yet to pay about 80% less. Obviously, each one of you with a different configuration, there is an option to run part of the cluster on on-demand resources and part of the cluster on spot resources, so we can always mix and match. We see that for companies that running heavy Scylla clusters want to do it and save some money. And that's the best part of the presentation. We're doing it just because, as you know, the rent on the public cloud is very expensive. So we just help companies to probably to do 5x with their budget and to remain on the same cost. Because think about it, if you're lowering your cost in 80%, you can buy up to 4 to 5x more capacity for the same operational budget. So that's pretty much it.